thought I would tell a little bit of a back to the future story on advanced manufacturing, because this is an important year for the Council on Competitiveness. It's our 30th anniversary, and you think back to 1986 and where the country was when our council was formed to bring together CEOs, university presidents, and labor leaders, and now national lab directors to address the challenges for U.S. productivity and economic growth and standard of living. And at that time, I happened to be in the White House Office of Science and Technology Policy and had a title that was an interesting one, Assistant Director for International Affairs and Competitiveness. Competitiveness wasn't even used really at that time. It was really beginning of new thought leadership. But at the time, you know, our country was very worried about the trade and technology issues with Japan. We were dealing with predatory practices around semiconductors, the 1986 famous U.S.-Japan semiconductor agreement that had a huge impact on not only saving but revitalizing our industry with the creation of Sematech, a very important model, public-private partnership model. And I was just thinking with this 30th anniversary period, looking back myself, I was the person who got to write the briefing memo for the science advisor that went to President Reagan making the case for Sematech. But the reason I say it's a back to the future story today is because I remember when a Japanese official said to me in OSTP, he came in and talked about the D's of manufacturing. And I finally said, well, what D's are you talking about? And many of you in the room have probably heard this because it went into the lexicon of talking about manufacturing, that manufacturing was dirty, dumb, dangerous, and disappearing, and no one in Japan wanted to go into manufacturing, and young people were turning their back on it. And, of course, how could you be a great nation if you didn't make things? And fast forward, you know, in the work of the Council on Competitiveness, we have really articulated through our work and public-private partnerships that indeed manufacturing today it's smart, it's safe, it's sustainable, and it is surging. But back then, we had a number of problems that we're still seeing today, and this is why this is a back to the future set of comments, that we have to continue to design and make things at scale. And the scaling issue and the capital that goes with that is absolutely a national challenge. I was recently on a panel for a big conference that Singularity University had on advanced manufacturing, and there were some venture capitalists there from Silicon Valley, and one after the other they got up and said, well, we would never invest in any manufacturing. We're only investing in software, and we don't want to invest in advanced materials because it takes too long to characterize them. So this whole capital issue and how it relates to scaling and for production at scale is very serious for the country. And one last back to the future story that I'll just reflect on as well is our flat panel display industry. Every single technology path for displays, whether it was liquid crystals coming out of Kent State University, field emitters, polyplanar displays, you list the displays, there was a whole plethora of startups and activity. We never commercialized any at scale. And all of that innovation went to Asia because we never linked the capital and the manufacturing with the design and the early innovation. So today, going forward, you know, we do really know that we're in a manufacturing renaissance. Nick and Namsu have covered a lot of the technologies underlying that. I would just add to the plethora of the digital capability, you know, we're in the third revolution of the digital age, that we also need to talk about the fusion of the digital, the biotech, the nano, and the cognitive revolutions, and how they are also playing a huge role in how things will be designed and made and create value and jobs at scale. The Council on Competitiveness has been involved in manufacturing really for many, many years. We highlighted this. Nick, I'll mention this since you're here today in our National Innovation Initiative back in 2004, where when we were looking at the innovation ecosystem, it was hard for us to get people in the country that wanted to work with us on the manufacturing issue. I mean, you and I were pushing it, but everyone was saying, oh, we don't need to make things. You know, we're going to do the design and the advanced R&D, and everything's going to be in Asia. But we really believed that manufacturing was on the cusp of a huge revolution. We're seeing that today. So coming out of that work, the U.S. Council is very proud that we have helped pioneer a number of strategic public-private partnerships in this space, from the Endemic, the National Digital Engineering Consortium that brought together a number of big companies to work with our small and medium-sized manufacturers. How could you take high-performance simulation tools into the supply chain? And that proof of concept has really led to the Digital Design Manufacturing Institute of University of Illinois, one of our great NMIs moving forward. But also, we have teamed with the Department of Energy for the American Energy and Manufacturing Competitiveness Partnership, because we've recognized that advanced manufacturing has to be coupled with the transformation in advanced energy and energy productivity. And the two are very much integrated today. And some of the results of that collaboration, now in its 4th year, that we're very proud of, is the recent announcement of the High Performance Computing for Manufacturing initiative, led by Lawrence Livermore National Lab, and that will soon encompass the rest of our national laboratories and university and industry. And this is, of course, how using our advanced computational capability for both design and prototyping, and also understanding predictability and other forms of disruption that we can see through advanced simulation, we can actually jumpstart and really go into a new manufacturing future as well, combining, of course, with additive materials and automation and sensors and all the other things that go with this. Also, we have, you know, a tremendous new capability in advanced composites involving industry and universities centered at Oak Ridge. I don't know how many of you have heard of the company Locomotors, but it's a startup, and the first 3D printed car was actually premiered at the Council on Competitiveness Summit with DOE, and we're hoping to get that model actually in the Smithsonian as part of our 30th anniversary. But from design to actually printing the vehicle, it was a 6-month effort. It was tremendously innovative, and I remember the young CEO, Jay Young, stood up and said that Tesla was the last gasp of the 20th century auto fabrication system. And our chairman, Sam Allen from Deere, said, you know, we're going to be printing tractors and we're going to be printing drones on the battlefield. So this is very, very exciting. But let me also just quickly mention, I think this is out here. I hope everyone will pick up or go online to get the 2016 Global Manufacturing Competitiveness Index that the Council has done over the years with our partner, Deloitte. This is also a back to the future story, and it's really amazing. My colleague at Deloitte said, well, you know, Deborah, we did it 2 years ago. Do we really need to do it for 2016? I said, we have to. The data and the findings completely threw out what we had presented back in 2014. And even more exciting, and you can get this, I should have brought this chart, projecting into 2020, the Back to the Future story is that CEOs around the world believe that the U.S. will be the top manufacturing country, China will be in that group, Korea, Japan, and guess who are the only 2 countries in Europe that CEOs around the world think have a manufacturing future? Germany and the UK. And also, the finding that the most important set of issues are talent-driven innovation, it gets to the workforce that we've been talking about, and also ensuring that a country has its tax, regulatory, capital formation environment in place so that it can capitalize on the innovation. I want to close with 3 areas that I think are huge for the country. We're going to be calling out initiatives for this at our 30th anniversary, where we present our competitiveness strategy to the new president. We have to double down and completely accelerate in a new way our leadership in high-performance computing. Many of you know, Nick knows of this, of course, China has surpassed us. This is very, very serious for the United States for many, many reasons, including national security. We have to also focus on the cybersecurity issues, because this whole digital production system that we're talking about and all of that is extremely vulnerable to pernicious, pervasive cyber attacks. And that is something where the traditional technology paths are not going to take us to resiliency in the cybersecurity world. And then the third is the beginning of the talk, Lawrence Berkeley Labs leading this with some others, around what we need to do to move beyond Moore's Law in the whole fabrication of electronic devices and things. We have no trusted fab in the United States. This is a huge issue for our country. So back to the future, but the future really is to be one that's going to be very, very exciting if we can get together the talent, technology, investment, and infrastructure in an integrated system for productivity and growth and good jobs for Americans. Thank you.